A planet orbiting a distant star is probably unlike any of the hundreds yet discovered. For instance, scientists say that about one-third of this incredibly hot barren world, larger than Earth, could be made of diamonds. The alien planet, a so-called super-Earth, is called 55 Cancri and was discovered in 2004. The planet 55 Cancri is just 40 light-years from Earth and orbits the binary star 55 Cancri, which is located in the constellation of Cancer. 55 Cancri has twice the radius of Earth, 8 times the mass, and because it's the innermost planet in the 55 Cancri system, the planet has a surface temperature of 3,900 degrees Fahrenheit 2,150 Celsius, and its year lasts just 18 hours, as opposed to Earth's 365 days. The planet is so big that its gravitational pull tugs on its parent star. This causes it to wobble back and forth in ways that can be seen from Earth. When it formed, instead of accumulating water, a substance whose molecules contain 1 atom of oxygen and 2 atoms of hydrogen, this planet probably accumulated other light materials. 2 likely candidates, carbon and silicon. Scientists had previously suggested that 55 Cancri, discovered in 2004, was covered with a light material, such as water. The core of 55 Cancri might be made of iron. So is Earth's. But the faraway planet's outer layers could be a mixture of carbon, silicates, minerals that contain silicon and oxygen, and silicon carbide, an extremely hard mineral with a very high melting point. Analyses of light from the parent star now suggest that its chemical composition, as well as that of the planet, is carbon-rich and oxygen-poor. Scientists say the rocky world is composed mainly of carbon, in the form of diamond and graphite, as well as iron, silicon carbide, and potentially silicates. At least a third of the planet's mass is likely pure diamond. But why is 55 Cancri made out of diamonds? Because the star system itself is primarily made up of carbon, iron, and silicon, and over millions of years of pressure and heat, the planet's carbon mantle has slowly turned into diamond. Planets like this are vastly different from our Earth, which has relatively little carbon. The revelation of the planet's diamond nature means that it could have very different thermal evolution and plate tectonics processes than Earth, which could create bizarre types of volcanism, seismic activity, and mountain formation. There could be other planets out there with different chemistries, too, water planets, gold planets, uranium planets, and each are likely to have very different atmospheres, biologies, and geological, tectonic characteristics.